Okay, we talked about a little bit about operators like plus that adds two things together, so you can have a plus b, and a divided by integer divided by b, things like that. Turns out that there are a whole bunch of operators we never covered in the language, and some of these you have to understand some representation inside the language to understand. It isn't just natural that you would understand these. Now, inside a computer, basically we have two values. This is the simplest way to look at it. This is not the real way, but it simplifies it and it'll give you an understanding. We have a voltage of 5 volts that says that something is a 1. And we have a voltage of 0 which says something's a 0. So this is the voltage, and this is what it means, the information. Okay? And this is what we call binary, because we have two values, 0 and 1. Now, with 0 and 1, I can make numbers. I could say 0, okay, that's a 0. I could say 1, that's a 1, but then I don't have any more. So if I want to do a place value on this, what I'll do is I'll do 1, 0, and that's a 2, and then 1, 1, and that's a 3. But then I have all 1s, and I'm going to have to make it bigger. So I could do 1, 0, 0, and that's a 4. But if I keep doing this, I can have my binary values and my base 10 values, and I can represent numbers. Now, this is not the only way we can represent numbers, but suddenly I've started talking about a base. And computers mostly work in base 2, which is binary. The signal is either 5 volts or 0, so we just make bigger numbers with fewer values. And we can convert back and forth between these. Yes, I can figure out from this that 1, 0, 0 is actually a 4. And that means that if I want to make it bigger, I'll do 1, 0, 1, that's a 5. 1, 1, 0, that's a 6. 1, 1, 1 is a 7. And again, they're all 1s. I've run out of places to put zeros. I'll put 1, 0, 0, that's an 8. And I can continue on. So if you talk about how big a number this can represent, then the more 1s and 0s that I have out here, the bigger the number. Now, usually what the computer is doing, okay, I think this is pretty universal, is if it isn't a 1, it's a 0. So these are actually filled in with zeros. So when we talk about numbers in a computer, they're either 1s or 0s, and we end up with big numbers. Now, if you go through all of these, you'll find that in 4 bits, we can represent 16 values. In 8 bits, okay, if it's 8 bits long, we can represent 256. And for various reasons, 256 was enough to represent characters and a lot of stuff. So this is a really common size for people to have worked in, and we call this an octet or a byte. Okay, and usually the simplest characters that we represent, like the American alphabet, the Latin alphabet, is represented in a 256-bit value, and we use numbers to represent them. So everything the computer does is a bunch of numbers. It's 1s and 0s, and we represent it this way. This means that all the operations like add or divide, everything is done on these binary values. Now, there are other operations that are native to binary values. The first one that I'm going to give you is AND. Okay, and I'm going to have two values, A and B, and we're going to AND those together, and we're going to get a result R. Now, what are the possible values for A and B? Well, they could both be zeros. One of them could be a 1. The other one could be a 1. Or it could be two 1s. Those are all the possibilities of A and B. I haven't left any out. Now, if I say A and B must both be true, then where in here do we have both A and B representing a 1? A true value where it's turned on. Well, in this one case down here, which means all the other cases must be zeros. If I have neither A nor B, it's a 0. If I have just one of them, okay? So this gives us what we call a truth table. Okay? Truth. There we go. That looks more like truth. A truth table for and. Now we can do the same sort of thing for or, and it turns out that there are two different ors. There's or and XOR. Okay? But I'll have A and B, and we'll show you what happens here. Okay, and I'm going to do or in this column right here. So A or B, and I'm going to use a little vertical symbol. Up here we'll use an ampersand symbol. And we'll say A and B. And what are the possible values? Well, they could be zeros. One of them could be true. The other one could be true. And that's all the values I can have. Now, if neither one of them is true, this is a false. If one of them is true, that's here and here, it's a true. Now, one of them is true here and one of them is true here, that's an or. It turns out that that's true. Now, when you go out to a restaurant and, you order dessert, and the waitress comes up to you and says, would you like pie or ice cream? Okay, she's not expecting an answer of, yes, I'd like pie or ice cream. She isn't going to expect that. She wants to ask you, do you want pie? Yes. Or do you want ice cream? Not do you want both? Okay? Now, this wanting one of two things like this is what we call an exclusive or. So that's where, no, I don't want any dessert. No, I don't want both. I only want it to be true if I'm picking one or the other, but not both. And that's what we call an exclusive or. And I'm going to put a little caret symbol for that one. That's a little upside down V kind of a symbol. So those are kind of the Boolean operators. And we actually have operators like that in Python. So we're going to go and we're going to take a look at some of the operators. But before we do that, we're going to ask some questions about what would happen with numbers if I just moved the binary values back and forth. Because, one of the simplest things we could do is just take this whole bunch of numbers and just shift it over a little bit. What happens to it? So let's take a look at that. Okay, let's do something with numbers in our own normal system, base 10. Let's say we have 60, and we'd like to multiply that by 10. Now this is 60 base 10. I'm going to do that like that with a little line saying that it's base 10, because we're going to work with some binary numbers too. Now if I just want to multiply by 10, I can just add another 0. I can say 600. That's pretty easy. Now what did we really do? We said we've got this base 10, but if we look at this as 0, 0, 0, 6, 0, and I just shifted this over one position. I moved it in that direction by 1. So I've got 0, 0, 6, 0, 0. So I've done a base 10 arithmetic shift left. Now, I can also divide by 10 easily. I can say that I've got some number 50, and I want to divide it by 10. All I have to do is just shift it that way, and I get 5. Same sort of principle applies. Now you'll notice that all of these are base 10 numbers. So if we want to multiply by the base or divide by the base, we just shift the number back and forth. Okay? Easy, simple thing to do. Turns out we can do the exact same thing in binary, except we're shifting by the base, which is base 2. So I have some number, 101, okay, and in base 2, which is equal to 5 in base 10. And I want to multiply it by 2. I want to double that number. All I have to do is just shift it over and get 0, 1, 0, 1, 0, which is, base 2. And that turns out to be 10 when we convert it to base 10. Okay. Now you'll notice that what happened here is I doubled the number. I doubled it, which is the base. If I wanted to divide it, now 5 is not going to divide evenly. Something's going to happen. We're going to lose a little bit, but if I shifted it the other direction, I would divide it by 2. Now Python, conveniently enough, has two operators, which is an arithmetic shift left, and it has this for an arithmetic shift right. Okay? So we can actually go in We're going to do that in a minute and actually play around with these arithmetic shift lefts as well as messing around with the other operators. The only other binary operator that we're really going to look at is what happens when you take all the ones and make them zeros and all the zeros and make them ones. You just flip the bits to the opposite value. And what does that mean? But we're going to use that in a couple different ways. We're going to extract a piece of a number doing this. We're going to put some numbers in. And we're going to look at how these things work in the language so that you're familiar with the binary side of Python as opposed to the base 10 side.